Dear students, welcome back to another video by the Mathematics department. The chapter that we'll be looking at today is chapter 11, probability. Okay, so looking at page 2, right, let's understand what is this chapter. So probability theory is a branch of mathematics concerned with the analysis of random phenomena. Okay, so in short, when we study probability, the questions that we ask ourselves is, right, number one, what is the extent to which an event is likely to occur, right? So, and the second question, right, what is the measured, how can we measure this probability, right, using a ratio of the favorable cases to the total number of cases possible, right? So this chapter measures outcomes, right? And we would like to study what is the chances or probability of such events happening, right? So in order to do that, we have a formula, and this is a formula that we use to calculate probability. So the probability of an event happening is simply taken to be the total number of favorable outcomes, right, divided by the total number of possible outcomes, right? Okay, and in mathematical form, right, the total number of favorable outcomes can be represented by this expression n bracket capital E, right, while the total number of possible outcomes can be represented by small n bracket capital S. Okay, so let's look at the next part, which is what's the chance of getting heads when you flip a coin? Okay, so in order to solve this question, right, we have to answer a few questions first. Okay, so what is the total number of possible outcomes when you flip a coin? Right, so when you flip a coin, you can either get heads or you can get tails, am I right? So the chances of getting a head in this case would simply be half, am I right? Because there's only one case, or rather there's only one possible outcome for heads. Okay, and the second part, what's the chance of getting a number 2 on a 6-sided fair die? Okay, so what are the total number of possible outcomes for a 6-sided die? Right, you can either get 1, 2, 3, 4, 5, or 6. Okay, and the chance of getting 2 is simply just 1 out of 6, right? Okay, for a die, okay, right, it consists of 6 faces, which includes the numbers 1, 2, 3, 4, 5, and 6. Okay, and there's an equal chance of getting each number, okay, since we have a fair die. Okay, what's the chance of picking a red ball out of a basket of balls in a random experiment? Okay, so we can answer this question later. So let's look at some of the definitions first. Right, a what experiment is a process whose result cannot be predicted with certainty, right? A random event. Okay, for the sample space, is a collection of all possible what of a random experiment. Okay, so if you have been listening, it should be outcomes. Okay, a set of all favorable outcomes of a random experiment. Okay, this is an event. Okay, what is a result of a probability experiment? Outcome. Okay, and what is the notation for the number of possible outcomes in a sample space? It is given by small n bracket s, right? So what's the notation for the probability of an event? Right, we will use the notation capital P, right, and E, which denotes the event. Right, so for example, what is the probability of obtaining, right, an even number when you roll a fair die? So how we would represent is probability of even number, right? So something like that. That's how your statement should look like, okay? So, and lastly, the number of favorable outcomes to the event, the notation is given by small n, right, capital E. Okay? Right, let's look at the next page, page 3. Okay, so in this table, we are given a few rows which we have to fill in. So let's look at the first one, flipping a fair coin twice. Right, what is the sample space? That means what is the possible outcomes that can happen when I flip a fair coin twice. Okay, so this given answer is wrong. Can you please cancel it? Right, okay, because you flip a fair coin twice, you would likely to get two different outcomes. Okay, so here, the first possible outcome is HH, which represent heads, right? You could also get the first coin to be heads, the second coin to be tails. You could also get the first coin to be tails, second coin to be tails, right? And finally, the first coin tails, second coin H, right? So these are the 4 different possible outcomes in our sample space, okay? And the event, and what's the event in this case? The event is getting a tail, right? So how many events or how many possible outcomes do you have? So you see that we have 2, right? So that's why we have 2 over here. And the formula to apply is number of favorable outcomes divided by the total number of events in the sample space, right? So this should be 2 over 4, which equates to half, right? Rolling a fair die. Okay. What should be the possible sample space, right? We should be getting 1, 2, 3, 4, 5, and 6. Okay, so the number of possible outcomes would be 6, right? Getting a value smaller than 4, right? So smaller than 4 means that strictly smaller than 4 includes integers 1, 2, and 3. So the total number of outcomes is 3. And the probability of this event happening is simply 3 over 6, which gives us half. Okay, the third one, a bag contains 5 red, 3 yellow, and 1 green ball. Okay, so red, red, red 5 times, followed by 3 yellow, 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 lastly 1 green, so green. Okay, so the total number of possible outcomes would be 9. Okay, and the event of picking a red ball. So how many of such balls do I have? 5 red balls, right? So 5 favorable outcomes, so 5 over 9 would be the probability, right? The next one, letters in the word rabbit. The possible letters that can appear, right, for our sample space is simply R, A, B, B, I, T. Okay, and in total there are how many letters? There are 6 of such letters. And we would like to select a vowel. Okay, vowel means that we are looking at A, E, I, O, U. Right, so the vowels are simply A and I for our letter rabbit. Okay, so there are 2 of such favorable outcomes, and the probability of selecting a vowel would simply be 2 over 6, which gives us 1/3. Okay, the second last one, letters in the word thinking, you should be able to easily deduce. We have T, H, I, N, K, I, N, G. So these are the 8 possible outcomes in our sample space, right? And the event is that we would like to select a consonant, right? A consonant is everything except vowels, right? So it's all the letters except vowels. So in this case, we are looking at T, H, N, K, N, G, right? So how many of such events are there? 6. So 6 over 8 would give us 3 over 4. Okay, the last one, right? A bag contains this amount of objects, right? You can easily count that there are 11 of such possible outcomes in the sample space. And in this case, we would like to select a chocolate bar. But you realize that you do not have any chocolate bar at all in this bag, right? So what is the number of favorable outcomes? 0, right? So there's no such event. So 0 over 11 simply gives us 0. So what we realize that is that if we have probability to be 0, it means that it is an impossible event. Okay, so an impossible event would give us probability equals to 0. Okay. The next one, the event of selecting a chocolate bar from the bag of candies is an example of an impossible event. Okay. And the next one, a class of 3 Chinese girls, 2 Indian girls, 4 Japanese girls, total 9 girls, right? Okay. The event of selecting a girl, right, which is basically all girls. Okay, 9 of them, so 9 over 9 gives us 1. So when we have probability equals to 1, it is a certain event. Okay, so the event of selecting a girl from a class of girls is an example of a certain event. So for example, if I were to ask you what's the probability of the sun rising tomorrow, what would your answer be? Clearly, it must be equals to 1 because every day, right, the sun would rise. So it is a sure event, a certain event. Hence, right, the probability will be equals to 1. So in summary, right, we denote P bracket E to be the probability of an event, and this is important as a statement before you present your answers, right? And we realize that for the topic probability, right, the probability of an event, right, must be between 0 and 1 for all events, right? So if you were to calculate your answer, right, if your answer is more than 1 or less than 0, right, you know that you have to check your work because it is impossible for the probability to be more than 1 or less than 0, okay? And the probability of a certain event equals to 1 means that it's certain, right? The probability of an event equals to 0 means that that is an impossible event, okay?